All right. So you will have on the front of your packet, and even if you want to rip that front page off, you even could. It's just some directions that we're going to use. I'm going to be talking about them the entire time we're doing this anyway. Now, if some of you are watching this at a different time or later, this does not mean these programs that I have are going to be on every single calculator you ever get from Texas Instruments. We'd have to download them onto your calculator, so we can get the code for that and do that sometime too. But for now, I want to make sure everybody's got these. I just loaded them on the other day. I want to make sure somebody didn't do something silly. If you hit the program button, it's kind of right here up towards the top in the middle. You should have two programs on your calculator, Quad 5 and 2.2. So just pressing this button next to App should get you there. And those are the two that we're going to be talking about today. So what we're going to do to find these, the first one's up here at the top. We're going to be using 2.2 because, of course, as you can see, all these problems were given 2 coordinate points. So we're going to go down to 2.2. We're going to hit enter once. This comes up, program 2.2. To actually get it going, I have to hit it one more time, because then it's going to start asking me for values. Okay, what's the first point you have? Well, my first point is my x value is 1. Don't type both of them, just the 1. And then what's the y value in the first point? -1. And it's just going to keep asking me questions. Okay, your second point. My x value is 2. SU. My y value is 1. Once you get those and hit enter, magic happens. The calculator then tells me, if I wanted to know the distance, it tells me the distance in both the radical and the decimal form. It tells me the slope of the line, the midpoint. This is the slope-intercept form of the line, and this is the perpendicular bisector of the same line. I was in shock the first time I saw this. I was like, so that's why I'm like, yeah, steal that, extra credit. Okay, so what I want right now, though, is I just want the distance. And for the most part, I would use the radical solution, because on an ACT type test most of the time, that's going to be the solution you're going to get. You're going to get the radical on something if you were using it. So that's what we do. Now, if I wanted any of the other information, I could get it, but for this one, that's all I wanted was the distance. So I get my distance, and I'm good. So then, I'm just going to keep playing with this, because we're going to keep playing with the same program. I'm going to hit enter once. That's going to get me out of the program, and then I just start the process over again. So I can go down, I can hit program 2.2. It'll be different when we get to quad, but we'll talk about that when we get there. And again, to actually get the program started, I hit enter until I see first point. So I'm going to jump down here to the midpoint one. So I get down here, I'm like, okay, so 0, 1, 1, 3. And then my midpoint is going to be down here in the middle. Now this one, I don't care if you put 0.5 because I know you know it's a half. There's a difference sometimes when I think there's a value that you wouldn't know otherwise maybe. But in this case, yeah, I'm pretty safe you'd know that. I write that and I'm done, okay? So if I drew it, now some of you are like, but I know the midpoint. It's just add those up, divide by 2, add those up, divide by 2. I can do that faster in my head than I can punch all that, and that's fine. I'm good with that. I agree with you. I can probably get this worksheet done faster just looking at it and doing the answers than I can using the program. But it's nice to have just in case. Okay. Slope-intercept form of an equation. Get reset here again. Be careful when you're typing in your points, because again, if I don't type in the right values, it kind of isn't going to give me the right answer. Now here's the one that's a little different. Down here to the left where it says y equals mx plus I, because I guess they couldn't use b, I don't understand all the programming to know this. This is my slope, this is my y-intercept. So if typical slope-intercept form looks like this, okay, I would just type in y equals 1.25x plus 0. But here's where I would try to think a little bit differently. Again, if you're on an ACT type thing, they're not going to give it to you in a decimal form. So here's what I would do if I was going through this. Once I got through, I'd look at that decimal, and I'd hit math, enter, enter, and I'd actually rewrite it as y equals 5/4 x plus 0, because that's the way it's going to look when you see it on testing somewhere. But again, if you can think of a quicker way to get to an answer that you remember, I'm just finding the slope and plugging in the intercept. Go for it. Okay. So once we get through, oops, we got one more. I forgot, we got perpendicular bisector still. Move up a little bit here. Write the equation of the perpendicular bisector. All right, back to the program. So my first point, we've got -4, -1, and -1, -2. And again, it's still the same equation that you were working before. So it's still like this is my m and this is my b. So in this case, it would just be y equals 3x plus 6. Slope, y-intercept. So no fractions to reduce there. So that one came out really nice. That is the one out of all of these that I really like, because there's a lot of work otherwise to figuring out the equation of the perpendicular bisector. At this point, once I go below this, you notice I don't have 2 points anymore. Now, if I move this up a bit, heading towards the bottom of this sheet, we've got some different information. So we're going to get out of here. We are going to change up programs, and we're going to go to quad 5. Now, one thing I want you to notice on this, and it's noted on the directions in the front, once you get to your screen with the answers, and I'll show you on this first one, it won't make you wait longer here. So I still got to hit enter to get it going. Now it's asking for A. You're like, A. Remember, when you're doing things like this, this is the format all of these equations are in. AX plus BY plus C. In other words, the coefficient of my squared term will be A, the coefficient of my x term will be B, and the constant term is going to be C. So when I'm typing these in, I just look at my first coefficient. It's just the number in front of x squared. It's always going to be, oops, I forgot to write x squared. I should write it this way. I shouldn't write it with y. That's going to be confusing. But it's basically just whatever's in front of x squared is A, whatever's in front of x is B, and whatever's all on its lonesome is going to be C. Oh, by hitting program, because I was going to say I can't go out of this right now, I'm going to get an error. So if you hit program, quad 5, and then hit enter, you should be to here. I'm sorry, I misunderstood. So now, once I hit enter, here's how this one is going to work. This gets a little more interesting. For the discriminant, whatever is after this little block here, which he says equals plus or minus this 8 square root of 1. Now, it doesn't mean the discriminant is 8 square root of 1. What it means is I have to undo this. You're like, wait a minute, what do you mean undo this? I'm going to show you how I'd calculate this without the calculator, and then how this would work. This is the one part of this program I'm a little sketchy on. So if I was actually looking for the discriminant formula itself is b squared minus 4ac. So I could do that on my own. I mean, b squared minus 4ac. And if I worked this out, 16 plus 48 is 64. Okay. Here's what this program does, though, because it needs it for something else. It's going to take this and it's going to break this down. Well, I know the square root of 1 is 1. So this would actually be 8. Now I have to put it back into its square root form. What do you take the square root of to get 8? 64. So if you're going to use this for the discriminant, that's what you're going to have to do. Whatever value they give you here, you're going to have to think backwards. Whatever value is on the right of that, whatever I'd square basically that's what I'd do. I'd square whatever I get here. And I'm going to do another one because this is kind of screwy. So let me move this up so I can try and better explain this with another. We'll do both of them on this side because there's some on the other side for you to practice with anyway. So, all right, let me hit enter. Oh, I almost hit clear. That would have been bad. Now, when I hit enter, it just tells me my vertex values and my roots again. Okay? But again, that's not a big deal. If I want to use the program again right away, I have two options. I can either hit clear and then hit program and do it all again. Or if I want to use the same program, I can hit enter once and it'll just start me back over again. But if you get stuck and you didn't mean to do that sometime, just fill in some random numbers because otherwise you're going to run into some trouble here. So I've got -9 for my A, 1 for my B, 9 for my C. So you're like, okay, now how's this work again? All right. So I look at this, and right after the little dot here, I see 5 square root of 13. To get back to the value that I want, to get back to the actual discriminant, I need to square this. Now, if some of you are looking to get out of the program so you can go do this, hit enter once and then just hit clear. Okay, you're out of there. And then I can do 5 square root of 13 squared. Oops, I got to get my extra parenthesis in or I'm going to lose it. So the actual discriminant would be 325 if I did what I did in the example that we did without using the calculator. To me, that's more work than it's worth. Again, unless you forget what the discriminant is. Then it can help a little bit. But you've got to make sure that second parenthesis gets on if you're going to plug it back in. Personally, I think it would be better if you look at this and say, hey, 5 squared is 25, squared and square root cancel, and just type that in your calculator.
How did you find the 13? I didn't see it.
You mean when I originally did the problem?
Yeah.
Okay, let me get the program back up and we can take a peek. Okay, so I had, oops, wrong program. Oh, Hardy. And this is where you just type in something random and get out. Okay, quad 5. So I've got -9 and 1 and 9. So over here, I'm always looking for whatever's right after that little dot that's there.
Okay.
So, yeah, up there, and then I'm just going to square whatever that is.
Okay, that makes sense.
Okay? So that's the only screwball part of this whole formula thing and program thing that we've got, is this one part. The rest of these usually work pretty good. So let me move back over here. Okay, solve each by factoring. Here I want to know what the roots are. So I get my A, my B, my C, and whatever they say the roots are, 1 and -7, are my answers. If I were to factor that out and then set each of the sets of parentheses equal to 0, those would be the two solutions I'd get back. Because if I were to factor this, I'd have, oops, I should use M, +7 and -1 adds to -7, multiplies to -7 and adds to 6. And then when I'd set those each equal to 0, I'd get those same solutions back. So that's all I'm basically doing with this, is getting that in and working it out. So I'm like, okay, there they are again, in case I missed them on the last screen. But I'm going to keep using this formula. So I'm going to get to this next problem, and I run into an interesting issue. Okay, my A value is 1. What's my B value? Zero, good, because my squared term's coefficient was 1, so that's where the A came from. There is no n term. I have to use 0 because my constant at the end is -144, and I have to use that for C. So I get here, and it's like, okay, roots, -12 and -12. And I'm set. You're like, okay, this isn't bad. And then my last one is going to be finding my vertex. So again, I plug in my A, my B, and my C. And again, got to watch for those pesky negatives. And then the vertex is going to be right in the middle here. So if I were to graph this on the calculator, that point where they come together on both sides with my parabola would be -3, -10. So again, this is more, I like to say, it's our backup plan for making sure we know what's going on. But here's the one other thing that I want to make mention of. Because every program that you ever run into is going to have some quirks. So let me show you the two problems where there's some quirks and how we'd actually deal with this stuff. And actually there's three, I'm a fibber. On the back, even calculators can have their issues. All right, let me enter and clear out of there. I'm going back to 2.2 for a minute and do number 1. So if you're in the middle of another one, whenever you get done with it, head to 2.2 here and do number 1 on the back. And I'm going to try to explain to you where the issue is coming here. Error, divide by 0. And I see why. Because remember, this program's trying to do everything. It's doing distance and midpoint and slope. Well, the problem is when it goes to do slope, it's going to get a division by 0 issue. So we're actually going to have to, I know this is a scary thought, we're actually going to have to figure this one out on our own, but let's think about it for a minute. I'm going to draw a picture, but I don't even think we really would need one. If I were to plot these points, 2, -4, 0, -4, how far is it between those 2 points? 2. So do I really need a calculator for that? Probably not. So if you do run into one where it's like error, uh-oh, what do I do? You don't worry about it. You just figure it out in your head for these couple of rare ones, and I go on to the next problem. 2 other ones that are going to be like that. 15, which is also a 2.2 expression here. So 2.2. -2, -5, -5, -5. Ah! It's that division by 0 again. So I start to look at this and I go, okay, I need an equation that goes through those 2 points. But I start to look at it, and there's a reason for this one too. Whenever you're trying to find the equation of a line, if you get an x or a y value that's identical, which is what's causing the problem, that tells me what the equation of my original line is. The y value is -5. That's my original line that I'm looking at. So when you think about perpendicular lines, we always remember, okay, they're going to make a right angle. A y equals line is the one that's going horizontally. I need the one that's going, or a line of some sort that's going vertically. So basically all you would have to do is pick one of your 2 x values and use it, because that'll make perpendicular lines, one horizontal, one vertical. That again is why the error message is coming up. So anytime you get the error message, it means, okay, this is simplistic enough, you're not going to need it for this. And then here's our last one. I'm saving the doozy for last. And then the rest of them all play pretty nicely. We're going to go down to 22 here. And we're going to go back to quad 5. All right, so we're going to quit. We're going to clear. And we're heading back to quad 5 here. So 22. Oops. Oh, Hardy. So we've got 10, 2, and 6. You're like, hey, it ran it. What's the big deal? Okay. Remember, when we're doing solve, we're looking for the roots. What's it say? Non-real. In other words, they're imaginary. Now, if you hit enter again, they're going to tell you this other value, but I'm going to guarantee you that isn't going to be what shows up probably on the ACT. You could try to take whatever they put in there as solutions and plug them in and see if your calculator will spit this out. But for our purposes of what we're doing right now, and more than likely what would happen on that test, we would just call that no solution unless it's telling us there are real values that'll work. All the rest of them on here are doable with the programs. You're not going to get error messages and stuff. So I just want you to take some time to play, because if you're playing now and then you're rolling along in the ACT and a distance problem or equation of a line problem comes up and your mind is out to lunch, hopefully you think back and go, wait, I can do this, and poke it and kind of help you with that question or two. That's the hope.